So this is my error E. But we are very much interested, instead of calculating E, let us calculate the mean square E. Mean square value of the error. So to calculate the mean square value of the error, let us have a look at the previous diagram first. So here, I ask you what is the minimum error that you can expect and what is the maximum error. The minimum error is 0 when the signal coincides with the quantization level, this value. And the maximum error will occur at this point somewhere here. So the deviation is S by 2 towards positive, or towards negative, it may be minus S by 2. So for every level, if you look into, assume I have the maximum voltage and the minimum voltage, and here I have the quantization levels, say M1, M2, M3, M4, M5, M6, M7, M8, so on and so forth. Now in each and every level, the error with respect to this, the error would be either plus S by 2 or it may be minus S by 2. Maximum error that we can expect. Minimum is 0 when both coincides. So this is my M1, M2, so on and so forth. Let it be Mk. And this is Mk minus 1, Mk plus 1, so on and so forth. Let it be M. So this is the peak to peak value of the signal. Let it be. Peak to peak value of the signal. Right. Now you take any quantization level. With respect to that quantization level, the signal may have a deviation of either plus S by 2 or minus S by 2. In the previous case, if you observe carefully, the linear increase of the signal, if I take for a level, say, if I take for a level, let it be, my x-axis is M, my quantization level. And this is the error, let us suppose, E, or simply error, whatever. So during the first quantization level, I can have the error ranging from minus S by 2 to plus S by 2. As my signal is increasing linearly, so this is what I expect, the error. Initially it is minus S by 2. When the signal coincides, it becomes 0. Then again it becomes plus S by 2. This is during the first quantization level. Similarly, during the second quantization level, I can have similar thing. During the third quantization level, I can have the similar thing. Fourth quantization level, so on and so forth. So this is my M quantization levels. So this is the error plot that we can expect with respect to the quantization levels. You take any quantization level, the minimum value is minus s by 2 plus maximum value is plus s by 2. Is that clear? The pictorial representation of quantization error. Is this clear?
Yes, sir.
Yes, sir.
Okay, fine. Now, I said we are interested to calculate the mean square error of the quantizer signal with respect to m of t. So the mean square value is always given by, here if you observe, in this region, say delta 1, your signal voltage can be in the region delta 1, or it may be in the region delta 3, or it can be in the region delta 7. Anywhere it can be, right? So the possibility that my signal is in this region, is called the probability of signal that lies in delta 1 region. This can be represented simply as say F1 in region 1. Similarly, in region 2, the probability will be say F of 2, like that. Now I'm saying mean square error. Assume this is my M1. If this is my signal value, say M, then my error would be M minus M1. M minus M1. So I have to calculate the square of this. M minus M1. Okay. And we should also consider the probability that the signal lies in this region delta 1. So F of M. So this infinitesimal width, if I consider as dm, then I can integrate from this point to this point to calculate my mean square error with respect to dm. So this value would be say m1 minus s by 2, and this value would be m1 plus s by 2. I can simply write m1 minus s by 2 to m1 plus s by 2. So this is my mean square quantization error expression, where f of m is the probability of occurrence of the signal in this region multiplied by m is the actual value and m1 is the quantization level. So this error whole square multiplied by dm. So we are integrating for a period m minus s by 2 to m plus s by 2. So for this complete period we are integrating. So this is for with respect to quantization level m1. Similarly, I need to get the quantization level m2 also. So plus m2 minus s by 2 to m2 plus s by 2 f of m minus m2 whole square dm. And so on. Is this expression clear to you? This
Yes, sir.
expression. Okay. So the mean square quantization error integral m1 minus s by 2 to m1 plus s by 2 f of m minus m1 whole square dm plus integral m2 minus s by 2 to m2 plus s by 2 f of m minus m2 whole square dm plus so on up to the last level. Fine. So if this expression is clear, then what I do is I said my f of m for first quantization level is f of 1. Similarly, my f of m for second one is f of 2 and so on. And this value is constant. The probability value of occurrence of the signal in that region is a constant value. This value is also a constant. Because my f of m is constant, I can bring this f of m to the outside for all the terms. For all the terms. Therefore, my mean square error can be written as say f of 1 plus f of 2 plus f of 3 plus f of 4 plus so on. Integral uh, let this can be a let us assume x equal to m minus mk, let us suppose. So if that is the case, dm equal to dx. Okay, so this will be x square m minus m1 or m minus m2 or whatever is x square dx. And can you tell me how the limits are going to change? Limits, this is m1 minus s by 2, that is mk minus s by 2, mk minus s by 2. So how to change the limits then? Limits can be changed as, any idea? So if I assume like this, how my limits are going to change? I want limits for x, right? Not for m. Dx equal to dm. I want the limits for x. This would be, I think, mk is already there. So minus s by 2 to s by 2. ante. Correct. So now, can anyone tell me what is the value of this one? What is the value of this one? What is f of 1? F of 1. Hmm? I said f of 1 is the probability that the signal lies in the region delta 1. F of 2 is the probability that the signal lies in region 2 or delta 2. Now my question is, what is this within the brackets, that is f1 plus f2 plus f3 plus so on? What is this value?
1, sir.
Because the total probability is 1,
1.
this entire bracket will become 1, right? Fine. So therefore, my mean square error is now minus s by 2 to s by 2 x square dx. How much? You evaluate the integral and tell me. Evaluate the integral and tell me the mean square error, quantization error. I think you all know the integration, right?
Sir.
Yeah. Tell me how much, what is the quantization error after evaluating the integration and substituting the limits?
S cube
This,
by 12, sir.
mm,
S cube by 12.
s cube by 12.
Yes, sir.
Okay. But here, I think this f1 plus f2 plus f3 plus f4, this is the probability density function. So if this entire value is f by probability density function, then Fs will be the probability, total probability, and the remaining term will be s square by 12. This is the total probability. And this value is 1. So your mean square error quantization error is s square by 12. This is the final